Hello students, from today we are going to start solving Cbse previous year question. So throughout this series we will try to solve each question using two methods. In the first method we will use the shortest approach, assuming that the student already has a good understanding of the concepts around 90% and is familiar with the most of the terms. In the second method, which will be a bit longer, we will explain the solution assuming the student knows very little, around 10%. While solving the question, we will explain every how and why, along with the reasoning behind each step. So, this method will be a little detailed. In this way, we will continue this whole series. If we solve around 10 to 15 sample papers like this, our preparation will become very strong and we will be able to score above 90%. So all the best to all of you. I hope you will enjoy this series. So let's start. So there is a circuit here where capacitor is combined. So as we know that a parallel combined capacitor has equal potential. So by using this relation, we can say that ratio of capacitance of parallelly combined capacitor is equal to the ratio of their charges. If it has Q1 and it has Q2 charge, then ratio of Q1 and Q2 is equal to ratio of C1 and C2, where C1 is 12 and C2 is 8. So it will be 12 by 8. It means 3 by 2. So the ratio of their charges is 3:2 when we have equal potential. Both have equal potential. Okay. In the question, it is given that this 20 microfarad capacitor has a 50 microcoulomb charge. Here you can see 20 microfarad capacitor is minus 50 microcoulomb on the left plate of 20 microfarad. So here minus 50 microcoulomb at the left plate, on the left plate. So here it will be positive 50 microcoulomb charge, and this 50 microcoulomb charge will subdivided, will split in two parts. Okay. So this 50 microcoulomb is splits in two parts in such a way that their sum is 50. Okay. So some of the charge will be here and some of them will be here. So and their ratio will be 3:2. Okay. So you can say that if we multiply 10 on numerator and denominator, then it will be 30 by 20, which sum is 50. So it has 30 microcoulomb and it has 20 microcoulomb charge. And as we know that in circuit, capacitive circuit, the positive and negative charges on the plate of parallel plate capacitor is arranged in alternate manner. So if on this plate, on the left plate has a negative charge, then here it will be positive, and in this manners here again it will be negative on this plate, and on this plate it will be positive charge. Detailed solution. So 20 microfarad capacitor has a charge of minus 50 microcoulomb, okay, on its left plate. As we know In parallel plate capacitor, both plates carry equal and opposite charges. Therefore, we can say that the right plate will have a charge of plus 50 microcoulomb. Now, just like the current or water flow splits in two parts when it gets two paths, okay? In the same way, this 50 microcoulomb charge will also get divided. Some will go upward and some will go downward. Suppose that there is a Q charge here, then 50 minus Q will be here, and by using this relation C is equal to Q upon V, we can calculate Q. Here we will have to use a property which says that parallelly combined capacitor has equal potential. And here we need to keep one more thing in mind, that the charge on a capacitor is arranged in alternating manner. I mean to say, it has negative charge and then it will have positive, and again it will follow the same pattern: negative, positive, negative, positive, negative, positive. Why it is so? It is because of conservation of charge. Here you have two capacitor in series combination. It is combined with a battery which has potential V. So now negative charge will come out from this battery. Okay, this is your capacitor A and this is your capacitor B. So this negative charge will come to this plate, this capacitor. This negative charge will create an electric field within the plate, and this electric field will repel negative charge on the left plate of capacitor A. So every negative charge will be repelled and they will come to the right plate of capacitor B. Okay, and so at the end, this left plate of capacitor A will have positive charge, and on this plate will have same but in opposite charge, opposite nature. Since this part were unattached um, from left plate of capacitor A to the right plate of capacitor B, these things were unattached, and so it was neutral. So the amount of charge on this plate is equal to on this plate but in opposite nature. So in this manner we can say that charges on capacitor will follow charges on capacitor follow alternating pattern. It means it has negative, then positive, then again negative and positive. Similarly here, by following this rule, we can say that this plate will have a positive charge. Now as we assume that it has Q charge, so it will have 50 minus Q, and their ratio Q upon 50 minus Q is equal to CV. Capacitance of this capacitor is 12, so here 12 and here 8, and their potential are same, so it will be cancel out. So now from here, by equating this two side, we can find our Q.